we can start.
Okay. Do you want
Okay.
me to record the session so you can share it with others that aren't able to make today's session? If you'd like, I can record it.
Yeah, sure, sure.
Okay. Okay, then. So, hello, everybody. This is Gianna from Multicase. Nice to connect with some of you again. I have Suman Chakravarti, who's Chief Scientist of Multicase here today, and he's prepared to present QSAR FLEX, which is a new toxicity assessment platform designed to handle complex endpoints, read across assessments. And I believe for your purpose today, we're planning to dig into the nitrosamine assessment modules, which use a local similarity read across measure to devise some relevant surrogates that you can use for your assessment. So I'll go ahead and record the session, like I said, and Suman can get started whenever you're ready, Suman.
Okay, sure. Hello everybody,
Okay.
this is Suman Chakravarti here. So, uh, I think for nitrosamine, and particularly in the context of um, QSAR FLEX, what I'll just, instead of talking about the methodology and all, I'll first show you how it works, and then we can have a discussion on it. Okay, so that way you will have more context of what's happening, and we'll see if there are good demonstration for particular NDSRIs, and then we can start from here. How does this sound? And you can interrupt me anytime if you have questions or you wanna discuss something. All right. With that, let me start sharing my screen.
Yep.
Okay. Can you see my screen?
Yes. Looks
Okay.
good.
Yeah.
Okay. 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 Good. So I have few NDSRIs here, which are complex nitrosamines that are derived from the various drug APIs. And as you know, that these are the most important discussion. They are the topics of most important discussion right nowadays because there are no data available for them. And when I say data, I mean any type of carcinogenicity or animal carcinogenicity data to be specific. And so that's why I actually selected these few NDSRIs. Now, these are, as you can see here, I have stored the SMILES code and their name, So, say for example, this is this SMILES code for N-nitrosanalfazoline and N-nitrosanalidbolol and so on. So these are all NDSRIs, and what I'll do, I'll start QSAR Flex and then use them as the examples for demonstration. So let me start QSAR Flex. So this is the specific program that we are talking about, and it contains various different types of endpoints here. And QSAR Flex not only works for nitrosamines, but it also works for other types of toxicological, ecotoxicological, or physical chemical properties that you would like to predict about. But this is the most important module that we are going to use today, which is N-nitrosyl carcinogenicity. Because our objective is to find out if this nitrosamine is carcinogenic or not, or if it is carcinogenic, then what would be its potency, and can we derive the acceptable intake limits for this particular NDSRI. There is one more module that are sometimes needed, which is called n-nitrosyl cross similarity. But today we'll just focus ourselves on n-nitrosyl carcinogenicity itself. Okay, so first thing we do is copy these examples and paste it here. So this area, which is somewhat like data curator from Case Ultra, and works exactly like Case Ultra, is there for you to load your structures into the program. You know, and once you load, You can curate their structures if there are any problems, and then immediately they are available for any kind of evaluation or test. So yeah, you know, right now there are no problems; they're just fine. And I have selected this nitrogen carcinogenicity and we'll see evaluate. So this button is to start making predictions or evaluation for the chemicals that are loaded currently, and we'll just say evaluate. And so these are the results immediately came up. And what we can do, we can click on any one of them. Like say for example, if I take one example, N-nitrosopropranolol, and hit say click to view. And if we do that, yeah, before I actually do that, you might notice that number 17, N-nitrosozolmitriptan, it did not return any results. So it's empty. Every one of them has something that you can click on and see, but this one did not return any values. So why so? So let's go back to data curator and see what's the problem with that. So this is the N-nitrosozolmitriptan. Now, if we increase the size of this molecule a little bit, you should be able to see that in the N-nitrosozolmitriptan, the N-nitroso moiety is actually embedded in a aromatic ring. So when uh, nitrosamines are embedded in an aromatic ring, they are not of much concern because they are not cohort of concern. Only nitrosamine that we want to evaluate is aliphatic nitrosamines. That means either they are embedded in a non-aromatic ring or in a aliphatic cycle. So these are called, uh, alkene, alkane type of nitrosamines, where it's simply aliphatic amine type of nitrosamine. So this is not going to work. Only nitrosamines that are non-aromatic, and that means the nitrogen of the nitrosamine group is embedded in a non-aromatic area, then is going to work. There could be other aromatic rings in this structure. That's not a problem. Only time is the N-nitrosamine nitrogen should not be in an aromatic ring. So let's go back to results. Now, if I click on the N-nitrosopropanol, that's when the actual results will be visible. And let's wait a little bit. Here are the results. So here are query nitrosamine, which is the NMDSRI of and propranolol, the drug. And these are the results. That means it actually returns in terms of analogs. So these are the analogs of the NDSRI. The first row is the query chemical itself, and the consecutive rows are different analogs. So that actually tells us how this program works, how this particular module for nitrosamine works. It works by uh, retrieving similar type of analogs from a database of other nitrosamines for which we have data. That means we have uh, carcinogenicity data for these analogs. And if you notice, the first row, which is the query chemical itself, do not have any data for uh, carcinogenicity. And the carcinogenicity data is stored on these columns. CPDB TD50, LASA TD50, and Ames mutagenicity is mutagenicity data. So for every chemical, every other analog, you have either carcinogenicity or many times mutagenicity also. And that's why we are trying to use this program to find out analogs that might represent the environment around the nitrosamine moiety. Okay, so that's basically how it works. And every row represent one analog, and every column represent one property of the analogs. And the first row is always the query chemical itself. Okay, so let me explain the different columns that we have here. The first columns are, first three columns are obvious. They are ID of the analog, gas number, the structure of the analog. And then there are two important columns, one for the alert environment similarity and whole structure similarity. What are those? So alert environment similarity basically represents the similarity of the analog with the query chemical, but only based on the features that are present around the nitrosamine moiety. So as you know, that local similarity has much more relevance in terms of nitrosamines as compared to whole structure similarity. So here also for the first analog, you can see that the alert environment similarity is 0.5, almost 0.52, and the whole structure similarity is only 0.23. So that's because we do not have any data for larger nitrosamines. That's why we are using small nitrosamines. And obviously, if we put our attention on the whole structure, we are not going to have any kind of good similarity. Okay, then we have the next column are the names, molecular weight, the CPDB TD50 values. So these are the gold database TD50 value. Sometimes we might also have LASA TD50 value. Say, for example, in this case, we have both Ames mutagenicity and log P and water solubility. Okay, so these are the few properties that we are listing here. And these properties are listed simply to assess the suitability of the um, analog to be picked up. Now, how we are going to assess our acceptable intake of a query chemical, in this case the propanol. So our job as a reviewer would be to select one of these analogs, or one or two at least, that might have high environment similarity with the query chemical, and on the basis of their carcinogenicity value, we will calculate the um, acceptable intake for the query nitrosamine also. Okay. So what should we do? Uh, First thing we should check what are the analogs that are on top. So, you know, these are on the top based on the alert environment similarity. Higher the alert environment similarity, closer it gets to the top. And then we should check visually using our own judgment how the environment around the nitrosamine moiety looks like as compared to the analog. Okay. And then we should check if we have good data, good carcinogenicity data for them or not. Now, what do I mean by good carcinogenicity data? So, in the toxicological, you know, area, good means robust. And what robust means? That, when we look into this actual carcinogenicity study of these analogs, they should have been performed on adequate number of animals. They should have been performed on a adequate amount of time or a period of time. Also, they should have at least three dose groups. Those are uh, robust data. If it is less than that, then it's not actually robust data. But sometimes we do not have any choice. You know. So, for example, in this case, we are lucky that out of these first two analogs, one of them has robust data. That means it has data from both gold TD50 value and LASA TD50 value. Now, how do we know if it is robust or not? So, the moment you take your mouse cursor on these values, you will see that it's getting highlighted. That means you can actually click on it. And let's do that. If I click on this particular nitrosamine carcinogenicity data, you'll see that it gives you a window with all the information related to the related to the nitrosamine. So here you can see that every different type of study is listed in terms of what is the duration of the study, how many number of animals were used, and what are the dose group for each study. So here you can see that the number of, the study duration is just fine. 100 weeks is not bad. Number of animals is also 80. But look at the dose group, just one. So that means only one dose group was used, and will create problems for calculating the TD50 value and it will have less statistical significance. So this TDFT value that we have for this analog will have less confidence as compared to this one, because if you click on it, the next one, you will see that it has been performed on 100 weeks and 80 animals, but the number of dose groups is 3. So we have more confidence on this TDFT value as compared to this one. Okay, so that is called robustness. And if we have also LASA TDFT values available, we should use the LASA one, because it has been recalculated from the goal TDFT value later on by the LASA people, and they have done a pretty good job in calculating it with more confidence. So this analog number 133 would be more suitable for us for determining the AI value. But before we actually select it, we should look into the neighboring groups around the nitrosamine moiety for the query and for the analog that we are trying to select, and see if they match or not. So the most important group is the alpha CH2 group. This one, if I don't know if you can see it or not, but the CH2 group which is next to the nitrosamine nitrogen is the most important one. So in this case, there is one CH2 group available for hydroxylation, but on the other side, it's isopropyl group. But in this case, in the case of the analog, we have CH2 group on one side and CH3 group on the other side. However, the important thing is that it's more conservative. That means it's most likely that the analog is more toxic as compared to uh, the actual query, you know, because the query has the isopropyl group on one side and the analog has methyl group on the other side. So the diazonium ion that will form will be more likely to be more toxic in the case of the analog, the number 133 analog, as compared to the uh, the query chemical. Okay, so we would select number 133 as our main um, analog to calculate our acceptable intake based on the groups around the nitrosamine moiety, based on the robustness of the carcinogenicity data.
Sorry to interrupt, Dr. Suman.
Sure.
Yeah, see here the objective, approach is fine that we should go with the conservative one.
Yeah.
Conservative limits are already published in the guidelines.
Yeah.
With 18 nanogram of TTC. So here objective should not be that it should be conservative. It should be because definitely if someone wants, he should opt for the higher limits, but with a minimal risk. That should be the objective
Yeah.
of this exercise, right?
Exactly.
Right. If we want to go in the direction of conservative, then there are few nitrosamines whose AI is already published in
Yeah.
guidelines. Any substructure matching to that can be selected.
Yeah.
But here,
So
in this particular example, where the isopropyl group is there and alpha carbon is sterically hindered, I expect that something which is less conservative should be the answer.
yeah. So you are right, but when I say conservative, that means conservative in terms of our analogs. So the conservative values that regulatory people have already published, that is actually based on even more conservative analogs like NDEA or NDMA, So we are not trying to go there. We are trying, when I say conservative, that means among these two analogs, which one we should pick, you know?
Got your point. Uh, uh, what about any analog which is having a isopropyl group in
Yeah.
adjacent to nitroso
Yeah.
group? That kind of
Yeah.
example is there in this output.
So we don't have those here. So the thing is that
But
if that,
I guess that kind of analogs must be there in the database of
not
CPDP
really,
or LASA.
you will be surprised at how small the database is. So in our
Yeah, I know, I
case,
know. We
i-
have our own database we made, and it is of 135 nitrosamines only.
yeah, so it's in your case 135, And our previous version was actually also 135, but now we have 194. But even
Okay,
now,
okay.
you know, you will be you will struggle to find very nice analogs. You know, so in this case, you are talking about isopropyl group. Just take out the top analogs. We do not have a single, you know, isopropyl group that was selected. Uh, I mean, that came out on the top. So it is. We wish that we would select isopropyl group, and I would have actually selected isopropyl group if it is available, but it is not available, unfortunately. So we do not have any other way to go. So we should be selecting from the analogs that are available. And in that, why I'm saying conservative, because this analog is more conservative as compared to this query, because it
Yeah, yeah.
has isopropyl group and it doesn't have
Yeah,
as the
got
reason.
your point. But here,
Yeah,
the that's what I am saying. Here, the objective should be that I should get an analog which can give me more relaxed value.
yeah,
It is
yeah, yeah, sure.
conservative as compared to my query, but
Hmm.
objective is to find the AI for the query.
Yeah,
If
yeah, I agree,
okay,
but we don't
yeah,
have that.
okay, it is not there in the
Unfortunately,
database.
yes, exactly. That's the reason. Otherwise, it would have actually um, shown that analog on top automatically. We don't have to even do real work. And sometimes you are right. I mean, sometimes what happens, the more suitable analog is not at the top. It might be somewhere at the few analogs below. So if you go a little bit down, you might find an analog which might be even more appropriate. But unfortunately, that's not happening in this case.
Yeah,
We do not
like
have.
14 number analog looks more appealing to me. If you can go to 14 number,
Yeah,
just
number
I have
14.
seen just one more below. Number 14, 1 4, ID is
Yeah,
14.
this one.
Yeah, this
You
one.
see,
See here,
this one.
if you see ethyl and then one hydroxy is there, ethyl one hydroxy is there, and from isopropyl there is ethyl group here.
Yeah. So in this case, you'll see that the problem is that one side is fine. I mean, it's kind of where this hydroxyl group is present. That is good. But on the other side, there is ethyl group, and ethyl group
Yeah, but it
means
is
another C.
more closer to as compared to methyl.
Yeah, but actually it's not. Methyl group is less reactive as compared to SL, because in SL there is a CH2 group, which is extremely potent in terms of hydroxylation. You know, so CH3 groups are less liable for hydroxylation as compared to CH2, CH3, and as you can see that the potency is higher, 0.022. If you
Yeah.
see the TDFT value, so you have to be careful in selecting a particular analog that satisfy all the criteria. Now, I don't know if
And
you have came
it is the
across.
user task.
Well, the software will help you in giving you suggestion at the top, and it will give you also all the data that are available for those analogs. But final job is the user's job to find out the most suitable one amongst few top. You know,
Okay.
and I'm going with this one particularly because it has at least some resemblance with the query chemical. Only thing is that it doesn't have the isopropyl group. You know, but if you go with this, your AI would be 142 nanogram per day, as compared to 80 or something, or say 26.5. So 142 is much better than 26, I believe, and
Yeah.
that's the pretty much we can do. And we are lucky in this case that we got an analog. In many NDSRIs, you will not actually get any suitable analogs, and then you have to go with the extreme conservatism, that is 18 nanogram or something like that. But we believe that in majority of the case, at least the program gives you the ability to get the chance to get a better analog as compared to NDEA or NDMA. By the way, I just published a research paper a few days back. I don't know if you have seen it or not, and I'll show you the paper. Hold on. And in that paper, I actually published the um, the calculation of probability of alpha hydroxylation.
Yeah. That is 23 paper. It is not available yet. Not published. We have
No,
gone
it's
through the.
published.
It is
It's
published.
published now.
I have
Yes.
gone through the that uh, abstract only. Okay, fine.
No. So this is open access. So you don't have to like have any kind of subscription or any payment to get this paper. It is published. I'm going to give you the um,
You can share the
TOI.
PDF only.
You can download it. It's free. You
Okay.
just the moment you click, it will immediately download. You don't. I mean, it's no. There is no. Um, we published it in such a way that everybody can get the PDF. You know. So hold on. I'll, I don't know how to get the. Okay.
Yeah, got it. Got it.
Just where is the chat? Yeah, here it is. Okay. So this is published. You can check out the paper. So here what I did actually, I calculated the alpha hydroxylation probability of large number of NDSRI scaffolds. And you can see that I also, you know, sorted them based on how much potent they are and how much less potent they are. So here you can see that if there is a hydroxyl CH2 group near to a aromatic moiety, it will be really high probability. And and if you go down, if you have something like this, which is actually propranolol, it will have less chance of hydroxylation as compared to um, you know regular NDVA or NDMA. And I also published for cyclic nitrosamines. There is a different table for cyclic nitrosamine. So we just published it, so you can actually check it out if you want.
This
That
is a
will give
QSAR
you
based model
yes, it's absolutely QSAR based model.
and regulatory is accepting these kind of explanations.
Well, they never tell us that if they will accept it or not. But my discussion with the scientists, they are looking for more and more evidence. Uh, there is right now the situation is such that they are accepting read across based analog approach with all the evidence, but there is no guarantee. Like if you put something out, there is no guarantee that they will accept it. It's based on completely on case by case basis, and nobody knows what is their requirement. Only thing that we can do is to try. Okay. So as far as the QSAR Flex is concerned, we have developed it in collaboration with FDA. So I hope that they have much, at least they know it intimately, they understand the methodology, and and if you present your case in a proper manner, you have a better chance.
Any
Okay.
examples you have where QSAR flex reports are accepted by uh,
No,
agencies?
no, I don't have any
Okay,
because there is no uh, data that we have. The only thing that I told you already that we have developed it in collaboration with FDA.
okay.
So they have worked very closely with us for years actually to get this thing going, and that's that much I can tell you. Okay, so once you have this table and you know what are the analogs that you would like to, yeah,
One more thing, Dr. Suman. That
yes,
probability of alpha hydroxylation is also there a part of this outcome?
not yet. It just the
Not
paper
yet.
is just published like a week ago. It's very
Oh,
fresh.
okay.
So right now I can tell you that we are working on putting it in the program.
Okay,
Okay, but the because it was we were waiting for this paper to get published. All right.
fine.
So uh, now what is the importance of this Ames mutagenicity column here? You can also click on any of these mutagenicity values and see the underlying Ames data. Say for example this one, and you'll know what kind of um, uh, strains the nitrosamine was tested and what is the result. Now, the thing is that majority of the NDs or the analogs will be positive in aim stress. However, sometimes if you have Ames negative analog and it is also very close to your query chemical, that actually is a good type of evidence because usually the negative Ames data also indicates lower carcinogenicity. Although if you only provide Ames data, the regulatory people do not approve it because they don't think that negative Ames data is the only is enough to to tell about the carcinogenicity of the NDSRI, you know. But it will be valuable for us to show the data if it is negative. Now, the other thing is that I would like to mention here is that you might notice that some of the values come up with asterisks on top. So anytime you see an asterisk in any value in QSAR Flex, that means it's an experimental data, not predicted data. So these are all experimental data that you see with asterisks on top. That is not the case with in log P or water solubility because these are predicted values. But sometimes you can see also asterisks on log P or water solubility, like for example this one. So we present experimental value if it is available. Otherwise, we predict log P and water solubility in the absence of experimental data. Okay. So this is our QSAR Flex program, which is based on the read across of suitable analogs. And the read across is done on the basis of local similarity, which is considering the environment around the alert and giving you the best possible analogs from which you can calculate the AI limits. Now,
Sir, any
if
supporting advantage we can highlight with log P and water solubility?
so log P and water solubility gives you an indication of bioavailability. So if something is extremely low water solubility or log P, then it is not bioavailable. And usually, if something is not bioavailable, it would be less, right? So if there is a compound like that, then you can at least know that this might have lower carcinogenicity because it's not bioavailable. So
Uh,
that is the reason why we have log P and
no,
water
Dr.
solubility.
Suman, uh,
Yeah,
I have a bit different opinion on this.
sure.
As GI tract and oral cavity is exposed with these
Yes.
compounds,
Yes.
it need not to be bioavailable.
Yeah, I understand that.
I guess it should be bioavailable showing systemic tumorigenesis,
Mhm.
but GI tract and oral cavity are directly exposed to the compound
Yeah,
and it
yeah,
may show the tumorigenic activity there.
yeah. However, there is another problem in that. That is, the nitrosamine needs metabolic bioactivation
Yeah,
to
yeah.
become carcinogenic. So in GI tract, we still have some enzyme that can convert, the nitrosamines to the bioactive, but it is not as good as the liver.
Liver, yeah, right. But intestine is a good potential for
Yeah,
metabolism. I
certainly.
think not all CYPs, but
Some.
certainly few CYPs are there which can.
Mhm, mhm. So you are right. So in the case of bioavailability, if something is causing, say, liver cancer, those things will not happen in the case of non-bioavailability. But you are
Yeah,
right
right,
that the
right.
GI tract is exposed. Okay, and other thing is log P and water solubility gives you indication of the clearance of the nitrosamine, how fast is going to be cleared out of the body and something which is extremely water soluble may cause urinary bladder cause cancers as compared to some other organs. So you get a little bit more hints from the physical chemical properties, and we have included two. Okay, but so far all the research that I have seen, including our own research, the main potential of or the main important thing is the evaluation of the surrounding features around the nitrosamine group and checking, alpha group. beta group, and so on. Because that gives you the ability to find out if it is going to be fast hydroxylated or slow, and if it is hydroxylated, what is the nature of the diazonium ion. Okay, so um, I would ask you to go through the paper also if you find something useful or not. We
Yeah,
just
sure,
published
sure,
it,
sure.
uh,
Uh,
and there you can see that in that paper, all the research that other people have done, it actually not only confirms that those findings, but it also adds a lot amount of functional groups as compared to anybody else.
okay.
So
One more
yeah,
thing.
please. Yeah,
Yeah, when you click the CPDP TD50 and we are getting a list of all the studies with
yeah,
the number of animals, dose and all, uh,
mhm.
statistical significance of that study, uh, I, I, I I could not see that. I mean, p values. That is
Yeah.
also
So
important.
yeah, it is important, but we did not include it because sometimes it's hard to get for all these studies. Uh,
Yeah,
so only thing that usually is important in a quick manner, that is the study duration, number of animals, and the dose groups. So these three things are the most vital one, and they will give you an indication of if the study is robust or not. And also the other indication is that if both LASA value and CPDP values are available, usually it's a more robust study. Usually, you know, that doesn't mean that everything else that do not have LASA value is not robust, but usually it is like that. But we did not include any p values yet.
yeah. One more thing is there. CL90. Sometimes, if you will see the guidelines,
Yeah.
they are not recommending the TD50s if they are coming on the higher side. They are taking the CL of 10.
Okay.
So I can
Conference.
give you one example. You can take an example of diclofenac. You can go through the ICHM7 where
Mhm.
they have uh, given a surrogate structure, and for that surrogate structure, they are not recommending the TD50 of Lhasa or CPDP, but
Uh-huh.
something which is of the lower confidence interval.
I see. I'll check that out. I
Yeah.
have not much knowledge about that.
Okay.
I'll check it out. You are
Yeah.
talking about diclofenac.
Uh, just
Is
a minute.
it plain diclofenac or some nitrosamine analog of it?
Nitrosamine. I am talking about. Just a minute. Let me uh, see it once. Exact. I will give you a gas number of that. Uh, Mefamic acid you can take mefamic acid and
Mefenamic
N
acid.
N nitrosomefamic acid.
I see. Hold on.
Okay, you can go through the ICHM7 question answer session. There you can get an example where they are
Mhm.
applying CPDP, applying the lower boundary of 99% confidence interval of the
I see.
TD50.
Okay. Okay. So I'll discuss this thing with my colleague Dr. Rustam because I'm not very knowledgeable about the toxicological studies. He knows a little bit more, so maybe he would be able to give us more uh, proper guidance in that respect. I'll check that out. Let me run at least mefenamic acid. Okay. So here you go. So mefenamic is a good example of actually good that you mentioned it because you know in the case of mefenamic acid you do not have any alpha hydroxyl group available,
Right.
alpha CH2 group. So it is going to be a really not cohort of concern, and which is reflected in this case. The CPDB is really high because this is the closest analog that we have here.
Yeah, you can check its AI limits. From this, it is coming 167, uh,
Mm-hmm.
whereas in guideline it is given 78 nanograms.
78 nanograms,
Yeah, just let me see.
which is
No,
very low.
78 micrograms.
Yes, micrograms, exactly. So this is 167 milligrams per kg, So
Yeah,
if you convert
if
it
you
to,
will convert into the nanogram,
yeah,
it will be
it will be really, I think it will be in thousands and
uh,
thousands.
thousands and thousands, but in guideline it is 78,000 only. It is not
Okay,
160 calculated from 167.
160, yeah, I understand that. But,
So that kind of discrepancies are there. I mean, sometimes we are doing and calculating with the help of analog, but in guideline we are finding that they are
mm,
considering the 99% of
yeah,
lower limit of confidence interval and make it more conservative. So
hmm
if that kind of information will also be there in the this software, so
it will be
that
helpful.
will be really helpful.
Okay, okay, I'll check it out with Rustam if we can add this kind of data in the in at least when you click on it and this thing appears, you might, it will be beneficial if we show that sort of information also, right?
Yeah,
Okay, okay, good. So that's what it is right now. So as you can see in this case, mefenamic acid, it actually gave a very good analog, the diphenylamine based on the um, local environment. But the other ones are not good. Let's say the the next analog definitely is not appropriate because it
no,
doesn't
no,
have it doesn't have. Of
right,
course,
right.
it at least it has one thing good going on, that both the alpha carbons are blocked. So in that respect, it's okay. But this one is the best analog.
Yeah, true, true.
The number 170. So what do you think, Dr. Tuli? Is it does it look promising to you, the program?
Yeah,
Or
this is see. Parallelly, I will let you know that how we are doing the things. See, we have
Mhm.
a database of 135, whereas you said that you have 194. So that is the advantage, definitely, where you have a more nitrosamines in your database. Secondly,
Mhm.
similarity analysis. Also, we are doing similarity analysis, but it is more of substructure similarity
Mhm.
and shortlisting the compounds. And then we are going manually in the all
Yeah.
details of CPDP and LASA and all the studies,
Yeah.
carcinogenicity studies published. Here in this
Mhm.
case, it is on the single click of your mouse, it is coming. So these
Mhm.
are the few advantages. The only question is that regulatory acceptance of this, I mean, if these reports are uh, fairly accepted by the agencies, then it will give more confidence. Uh,
Sure. So right now, I don't know if you have attended that HESI meeting, which happened at the end of last month, on
okay.
30th, 31st. So there, when the FDA scientists presented their findings, they were also talking about QSAR FLEX at that time. So they were actually collaborating with us, and they actually specifically showed that slide, how they were considering the closest analog approach. Now, regarding acceptance, you have to keep in mind that there is no guarantee if you submit something from QSAFLEX, they will immediately accept it. It all based on case by case basis and what type of evidence you have um, put out. And currently, the most valid evidence is the closest analog approach with with the consideration of the local environment. And of course,
Yeah,
you
yeah.
have to understand other things like probability of alpha hydroxylation, bioavailability, the metabolic similarity, and all those things.
Yeah, true.
So that's and in the field is moving fast. We are also
Yeah.
contributing from our side.
So
We are also doing a lot of research.
yeah, fine. I mean, if the alpha hydroxylation probability will be a part of this analysis and regulatory agencies will endorse that kind of approach, then it will be really very
Yeah,
useful, very useful.
absolutely. And what we can do from our point of view, or from any other scientist's point of view, that we can only add one little thing. Like, okay, here it is. Maybe you can use it as one of the evidence. But at the end, after say few years or few months, um, the what I suspect is that things are going to change uh, fast, and uh, FDA just has started publishing slowly but steadily the other type of in vitro uh, assays, like enhanced Ames test or transgenic mouse. So they will be publishing more and more data on NDSR. They just published about
Tra
N-nitropropanol.
Transgenic mice is too costly and
Yes, exactly.
it is not available yet. We searched for that, and again, that is a 4 month study, which require
Yeah,
lot of quantity of impurity.
yeah, yeah. That
So
is true.
those all are the bottleneck of that kind of approach.
Yeah. So
So
so I
in silico approach is the best one if evolution will be there in this field only, and I expect that 194 database will increase to much more
yeah,
number.
I hope so.
Yeah.
But you know what? The thing is that FDA is going to publish the in vitro data
Okay.
they are conducting, and they already published it for the N-isopropanol, and that doesn't include. I don't remember it has transgenic mouse, but it has enhanced Ames data and other type of um, genotoxic evaluation. So they are good. We cannot prevent them from publishing things. They will publish it,
Yeah.
and that doesn't mean that we have to do them, but we can actually use them to create more better QSARs.
Yeah. Right.
And so that's what we are waiting. So
But Dr. Suman, look at this example only of mefamic acid, where the
yeah,
Ames mutagenicity test is negative.
negative.
But
Yes.
still we are getting a TD50 where carcinogenic potential is there in the molecule.
Mm-hmm. Mm-hmm.
Okay, so deriving a limit from TD50, which is recommended in guideline, is fair enough. But how in vitro test, which will give only answer of positive or negative, is going to drive the AI limits? I really don't know about that.
Yes. Yeah. I have the exact same question that how in which way it will give you the potency. However, what I suspect is that when you will consider all the evidence, you should still be able to find uh, from yes or no data, like what will be the potency. Because when you will perform Ames test, you will also get the idea of how many divertants per mole, what is the potency of mutagenicity, and when
But
you so you are
if you are getting a positive AIMS test, then also you have to drive AI50 from TD50 value only.
yes, yes. But if you get, say, look at this particular analog, it is 167 milligrams per kg per day, but the Ames mutagenicity is zero. That means it's
Yeah,
non-mutagenic,
negative.
negative. So, but in this case, it is easy because it's not cohort of concern, actually, because it doesn't have the available CH2 groups. So, if it is not cohort of concern,
One more question.
yeah,
When there is no alpha carbon proton available, then we
yeah,
can say that it is out of cohort of concern.
yes, absolutely, it is. So, Lhasa people, David Ponting, they published a
Yeah,
paper just few days back. Actually, it shows you what are the compounds that you can actually keep out of the cohort of concern. So one of them is 100% non-availability of CH2 group.
but
I mean,
agency
non-availability.
don't have any guideline on this.
Well, they will come up with the guideline later, sooner or later. They are still working
Because
on it.
yeah, because right now any nitroso impurity is a cohort of concern, irrespective of alpha carbon proton availability.
Yeah, but this is because the agencies take time to put things onto in writing.
Okay, okay,
We are faster than them, so we put things out, then they see, and if it seems valuable, then they put it into writing. And I'm sure that they are going to make it non-cohort of concern pretty soon.
okay.
But right now, you can only show evidence from papers. Like, okay, the paper says that it's not cohort of concern because of this non-availability of it cannot be metabolically activated too, and the TD50 value reflect that, right? Like,
Yeah,
think
yeah.
about it.
But
It
still, it
once
is having a tumorigenic activity.
activity, but you can control it in a much better way,
See, yeah,
right?
that's true. The thing is that one literature is there which I have gone through that nitrosamines are not only carcinogenic because of alpha after metabolism. Some
Yes,
nitrosamines can cause
yes,
tumors without even
directly.
going metabolic activation.
So those are definitely not in the cohort of concern. Those are like, say, for example, nitrosoureas or
Yeah, true.
nitrosohydantoins,
Yeah, yeah, yeah,
or so those are actually, there some of them are drugs, isn't it?
yeah.
Then there are lots of drugs that are nitrosoureas, anti-cancer drugs. They are not cohort of concern. They are out of. They are not directly. They are. They do not become cancerous after metabolic activation. They are direct. They can directly bind with the DNA. And they are lower potency nitrosamine.
Okay,
Because the alkylation is the most important part of making them potent. Okay,
okay.
so that's where we are, Dr. Tuli, right now.
So fine. I mean, fair enough.
Mm-hmm.
We'll have a discussion among ourselves and
Sure.
let us see. Uh, because see, in any organization, the expectations are these all things are to satisfy the regulatory agencies. So
Yes, yes,
always the expectations are that how fruitful these explanations or reports are in order to get a limits to save the products. So
yes, absolutely.
that is a key objective, and around that we'll have a discussion among ourselves and see the
Mm.
utility of this tool. Definitely, this tool is good and it is evolving. So
It
many
is
new
evolving.
things. It is evolving. I guess then when the database of nitrosamine will increase and some other important methodologies like alpha hydroxylation probability and all will add it to this software, and agency will sooner or later will start accepting
Yeah.
all these things.
So currently, the largest database that anybody has for nitrosamine analogs, that's the Multicast has the largest database, 194. Everybody else is below that because we just added a lot of new molecules to it from research papers. But
Yeah, Dovo and Jesse nitrosamines few 10, 15 are
yeah,
added to our database also, but still it is uh, very short database.
yeah, and it's not going to increase dramatically over the years because not much data is available. However,
Yeah,
data is coming out slowly,
yeah,
and not carcinogenicity, but at least say transgenic mice. Now, if you remember, just I think a year ago, Suzanne Gloinke from Novartis published a paper on uh, valsartan nitrosamine, and she published the data for transgenic mice, Ames data, and some other mutagenicity. So those are getting available slowly, so we can at
yeah,
least add the mutagenicity part as more and more data comes out.
yeah.
Okay.
Okay.
So thank you very much. One more feature that we have here is the save button. which actually saves all these analogs, including the data. So you can actually save all the data from carcinogenicity and mutagenicity directly into the Excel spreadsheet. You don't have to keep on clicking on them. Okay.
Okay.
So similarity matrix, if they want to see any advantage of that,
What is that?
similarity matrix.
Oh, no, I don't think that similarity matrix. Well, I'll show you if I can. Hold on just a moment. So what Yatindra is talking about is the uh, usefulness of this particular module, N-nitrosyl cross similarity. So this is for a different purpose. It is to compare nitrosamines. So suppose you have a few nitrosamines that are you want to compare them um, based on local similarity. So this N-nitrosyl cross similarity actually does that. So sometimes, suppose you have already found the limit for a particular nitrosamine and you would like to compare a new nitrosamine with, or there is a AI value derived by the authorities and you want to compare your nitrosamine with that one. So this cross similarity matrix will actually help you with that. So you can compare by putting a bunch of nitrosamines, not many, not tens or hundreds, but few, 5 or 6, and check how much different it is from ND. So this is NDEA. So as you can immediately see that this particular nitrosamine is extremely different from NDEA. You know because it has low uh, local similarity with this one, but higher similarity with this one. So it's a pairwise comparing of different nitrosamines. That also become highly valuable sometimes. You know.
Yeah, fine.
Okay. Thank you, Yatindra, for mentioning it. I forgot about it actually.
Thank you, sir. Thank you.
Okay, everyone. So
Yeah,
thanks, Dr. Tooley. And just be in touch if you have further questions related to the demo. I'll send out a recording so you can share with others who weren't able to make the session today. So we'll be in touch. Okay.
sure.
All right. Sounds
Thank you,
good.
Dr. Tuli,
Yeah.
and
Thanks,
all the
everyone.
Thank you,
other
Dr.
members
Suman.
from the torrent.
Okay. Take care, everyone.
Thank you.
Bye-bye.
Thank you,
Thanks,
Gianna.
Bye.
Thank
Jana.
you so much, sir.
Thank you. Thank you, Dr. Tuli.
Thank you.
Bye,
Bye-bye.
everybody.
Bye.
Bye, sir.
Bye.
Thank you, Diana.
Good day, Dr. Tuli.
Thank you.